That's true. Okay.
What do you have? Math?
That's why she's here.
I don't know. Some people have like core one, like integrated math one. And I have like
You have what? You had core 3? Why are you doing back in core 2? So I see.
No. 5.
Okay, so let's get this done. All right, so we're going to talk about. Let me get my little pointer because I love my pointers.
You're so nice.
Why? What?
Because you say hello.
I know. Hello, everyone. Oh, Israel. Nice. Nice to see you, Israel. Okay, guys, we're going to get started. And we're going to talk about some trig functions and the Pythagorean theorem. And you should already know the Pythagorean theorem, okay? A squared plus b squared equals c squared. Okay, so everyone should know that. But just in case you don't, like, make sure that you know how to manipulate that. All right, so we'll talk about that a little bit too. All right, so this is just an introduction to trig functions, and anybody who actually did week 9 in last quarter, this stuff is old news, okay? So if it seems to you, if you did week 9, and if this seems to you to be a repeat, it is. Okay, so trig functions are the relationship amongst various sides of a right triangle. So one of the important things to remember is that the only way that we can get these trig functions to work is if you have a right triangle. All right, so by now you know the Pythagorean theorem and that the sum of the squares of each side is equal to the square of the hypotenuse. A squared plus b squared is equal to c squared. Okay, everyone knows that, right? Give me a hands up or a smiley face or something, just if you know this. Good. Caitlin knows it. Gabby knows it. Davina knows it. James knows it. So Israel, are you the only one that doesn't know it? Israel? Uh-huh. Are you there, Israel? Okay, good. I said, do you remember the Pythagorean theorem? A squared plus b squared is equal to c squared. Okay, good. All right. So here's my triangle. It's kind of off the screen here. But this side is, the big letters represent the angles, and the smaller letters represent the length of the sides. So this is angle A right here. This is angle C right here. And up here is angle B, and you can't see it because it's off the side. So we know that in the above triangle, we have A squared plus B squared, these are the legs, is equal to C squared. So trig functions are how the relationship among these lengths of sides of a right triangle vary as the other angles change. So these angles, you're going to be able to figure out these angles using the sides of a right triangle. That's exciting, right? So this is how everything relates in this right triangle. So if you go back, I don't know if I can draw it or not. Let me see if I can. So here's my right triangle. It's kind of poor drawing, but that's okay. And if this is angle A, I don't have my little pen. This is angle B. This is angle C. Okay, so the side opposite the angle, oops, this is side A, side B, side C. So that's kind of poor as far as, you know, You might not be able to see it so well, but that'll help you when we talk about these sides. So the opposite side divided by the hypotenuse. So the opposite side for angle A, the opposite side is that side directly opposite. Okay? So it's opposite divided by hypotenuse. For angle A, if you want the sine, all right? For angle A, again, if you want the cosine, it's the adjacent side. So the adjacent side is that side that's right next to it, and again, it's divided by the hypotenuse. And the tangent then is the adjacent, so it's opposite divided by adjacent. So it's up here, A divided by B. Okay? So, one of the ways to remember this, in case, I don't know if you've probably heard this too, it's SOHCAHTOA, right? So, this first part is sine is opposite divided by hypotenuse. So, that'll always, if you remember that sine is opposite divided by hypotenuse, then you can, whatever angle you're looking for, you look for the side opposite and then the hypotenuse. Cosine. All right, cosine is the adjacent side divided by the hypotenuse. No matter what angle you're looking at in that right triangle, that's what it's going to be. And tangent, that's what the T stands for, is always opposite, so the opposite side divided by the adjacent side. Okay, so that's an important, what are those things called? Does anybody know? Where you use letters to represent it. I don't know what it's called, but that's pretty important to remember. SOHCAHTOA. All right. So we're going to go through a couple examples here. All right. Quit playing with my thing. All right, so example 1. Side A over here is equal to 3. All right, side C, so this would be the hypotenuse, and this is 6. So we want the measurement of the angle of A. All right, so this is kind of important. If you have, and they have these calculators, you could probably use a calculator in on your computer, but each lab has some graphing calculators, and you can use these graphing calculators also. All right, so what is the measurement of angle A? So here's angle A. I know that side A is 3 and side C is 6. What would I use to find the measurement of this angle? Which one of our trig functions can I use? It's okay. No worries. James. Anybody? Sine, cosine, or tangent? Which one of those can I use? Remember, sine is opposite over hypotenuse, SOH. Cosine is adjacent over hypotenuse. Okay, good, Caitlin, sine. Good, Stephanie, exactly. So if I used sine, and again, I forgot my pen, so sine of angle A is equal to opposite over hypotenuse. So it's equal to 1/2. Excuse me. And later on, when we get into just a little bit more, there are a couple of angles that are going to be really important to remember. The angle of the measurement of 30 degrees, you should remember the sine and cosine of that. 45, 60, and 90. Oh, and 0 also. So does anybody know what I would do in a graphing calculator, or do you have a calculator online that you can use to find out what is the angle measurement? What angle measurement is equal to 1/2? Anybody? Anybody? We are going to use sine. So the way that we work this out is in a graphing calculator, so one of the TI-83s or 84s that either one of the labs have, what you would do is you would put, there is a function and it's second sine, and it looks like this. That's what the button looks like. Sine inverse, this is what you're going to use, and then you're going to put in 1/2. It'll come up with one of those parentheses, and then you're going to close it, and then you're just going to press enter. And this is going to give you that angle A is equal to 60 degrees. Does that one have it, Gabby?
Yeah.
Okay. I'm going to wait. Caitlin is typing. Good question, Caitlin. So you use sine inverse when you have the lengths of the sides, all right? And you use the normal sine when you know the angle measurement, okay? Does that make sense? Okay, good. All right, so now, here we go. So the answer is A over C is the sine relationship. So for those of you that said sine, excellent. And sine of A is equal to 3 over 6, or 1/2, 0.5. And then you would use your inverse sine, and you would, 30 degrees. Uh-oh, my bad. See, you need to memorize those 0, 30, 45, and 60. You need to memorize those. Okay. So it's 30 degrees, not 60. All right, so now what we're going to do is we're going to look at how to apply this to a word problem. So we have a flagpole, and it casts a 100-foot shadow at noon. So you're lying on the ground at the end of the shadow, and you measure an angle of 25 degrees to the top of the flagpole. Now what we want to know is how high the flagpole is. So this is where we know the angle and we know a side. So what we're going to do is we're going to figure out this triangle, okay? Okay, so here is our right triangle, right? This is our angle that's 25 degrees. All right, and we know that this shadow is 100 foot. Again, I don't have my pen. All right, so if we know that this side right here is 100 foot, we know that this angle is 25, which one of the trig functions do you think we're going to need to use? Sine, cosine, or tangent? Because what we want to know is we want to know this right here. How tall is this flag? So are we going to use sine, cosine, or tangent? What do you think? Yes, Caitlin, excellent. We are going to use the tangent function because what we know is tangent is what? I'm going to write it up here. You keep typing there, Caitlin. I'm No, I'm almost done. Thanks, though. Okay, so tangent of 25 degrees is SOHCAHTOA. So it's TOA. It's opposite over adjacent. So we don't know what opposite is. That's what we want to find out. This is what we have. Opposite over adjacent. Okay? So think about some algebra here. How would you figure out what the opposite side is? How would you figure that out? How can you rearrange this up here, this equation, to find your x value? Exactly, Caitlin. And again, this is where you use the tangent, not the inverse tangent function. So if anybody has one of those calculators, you can go ahead and do that. But so it's opposite over adjacent, and that's what we wanted to use, the tangent relationship. We're going to let x be the height. James, you keep getting kicked out. Excuse me. We're going to let x be the height of the flagpole. And then from our calculator, we know that tangent of 25 is 0.47. So 0.47 is equal to x over 100. And again, like Caitlin said, if we multiply both sides by 100, we get that the height of this flagpole is 47, and it's feet, right? Because always use your units, guys. Always use your units. Units will help you. Okay, so does anybody have any questions about that? Yes, no, maybe so? We good to go? All right. So the height of the flagpole is 47 feet. All right, some more questions real quick. Angle A is 35 and B is 50 feet. So all I want you guys to do is to tell me what am I going to use? And again, think about that triangle that we had at the beginning with this is angle A, this is B up here, and this is C. What trig function am I going to use here? Tangent, sine, or cosine? And remember, again, remember that the sides, the length of them are opposite the angles. So, sine, cosine, or tangent? Which one? Gabby is saying sine. We know that. So what is sine? Sine is opposite over hypotenuse. So this over here would be the side opposite. This is the angle that we know. Sine, cosine, or tangent, guys? Everyone has to answer one of these, or else you have to go back and answer the question for the webinar. All right, so James says sine. Remember, sine is opposite over hypotenuse. We don't know what the A is, but we know what B is. How do I find C? Sine, cosine, tangent. Caitlin says cosine. Stephanie says cosine. Oren says cosine.
That's what I thought. That's what I tried to say about my voice.
Oh, okay. Okay. So Gabby said what she said was cosine. And yeah, I know she's feeling sick. So what we're going to do is I'm just going to press this, and it's going to be 61. All right. So cosine is the one that we would use. All right. All right. Let's go to the next question. If adjacent side is 50, the hypotenuse is 100, what is the angle? So what are we going to use here? Sine, cosine, or tangent? You need to put your phone away or give it to me, okay? We're going to use sine, cosine, or tangent, guys. We know adjacent is 50. Hypotenuse is 100. Caitlin says cosine. We want to know the angle. Gabby says cosine. James says cosine. All right, so it is going to be cosine, and let's look at 30 degree, oops. Let's go back to the question. Sorry, it's cosine. Okay, and it is cosine, because cosine of 60 degrees is 1/2. All right, good. Those of you that said the right one, yay. All right, now this is what we have. The opposite side is 75, and the angle is 80. So how long is the adjacent side? And again, all you guys need to do right now, because all I want you to do is to tell me, all right, what are we using, sine, cosine, or tangent? Here's your triangle, and let's say this is the angle that we want, right? This is 80 degrees. Which side is opposite? And I'm going to put, is this the opposite side, or would this be the opposite side? Number 1 or number 2? Which side is opposite? Okay.
Okay, which one was which?
Oh, sorry. This is number 1. This is number 2.
Number 2 is opposite.
Number 2 is opposite, right? Because we want the opposite side. So this side is 75 degrees. Good. Good, Stephanie. And we want to know this side. So what am I going to use? Sine, cosine, or tangent? I know I should have marked 1 and 2 as I was doing that. Caitlin, sorry. That could have been confusing.
Tangent.
Okay, Gabby is saying tangent. This is the side I want up here. Remember, so is opposite over hypotenuse. Cos is adjacent over hypotenuse. And tan is opposite over adjacent. Okay, I don't know. I can't remember what the answer is, and I don't have my calculator. So I'm going to just see if I can. Okay, we have a couple cosines, a couple tangents, and let's, oh, this one I don't have the answer. So actually what we would use is cosine, and I don't have my calculator. So what we would have is cosine, whoops, I need this. Here we go. So it's going to be, make sure I got this, cosine, oh, that's terrible, of 80 is equal to 75. Okay.
She said, what?
I know. Over x. That's terrible writing. But we're going to use cosine, guys. Cosine. And it's going to be, I'm so dumb. Opposite. It's not cosine. Who is paying attention? Obviously, Gabby. It should be sine. Sorry, guys. I'm so trying to figure out this. My typing is terrible. All right, so it should be sine of 80 is equal to 75 over x. This is an x. So if you guys have a calculator, I don't have my calculator, then you could figure out what this side is. Okay? I'm sorry, Stephanie. I know my typing is terrible, or my writing. Actually, the answer is B. I don't have it set up to come up, but it is B. All right, let's go. I think we have one more question. Oh, there you go. It did come up. All right. So now we have that angle B is 50 degrees and side B is 100. We want to know what C is. So what are we going to use? We know that this is 100. Sine, cosine, or tangent? And this is angle B. Sine, cosine, or tangent? We want to know this side. We want to know this side right here. No, remember, opposite over hypotenuse is what? Because this is the opposite. Opposite over hypotenuse. You guys, this is really important to write this down. I know you think I'm crazy, but again, remember that when you're doing your, writing is terrible. I don't know where my pen is. I think it's at home, that's the problem. And then TOA, T-O-A. So what trig function am I going to use? What trig function? I am going to use sine. Opposite. The side is opposite. So it's this one right here. Okay? You guys good with that? Okay. Answer. This is 50. This is 100. I don't know. So let's see. I don't know if this one is set up. Oops, that's not right. Again, I don't have my calculator, so it's 130. It should be sine, okay? Let me go back here. Oops, there we go. Do you understand that, Stephanie, why it should be sine? Because it's opposite. We know, okay, so we know this angle. Oops, sorry. Don't know what's going on there. Okay, we know this angle right here. We know this side, and so we know the opposite. What we want to know is the hypotenuse. Does that make sense? So we use sine. Write down that SOHCAHTOA, and that'll help you. All right, let's go. We only have a couple more minutes. All right, so two rays with the endpoints make an angle. So this is a ray, this is a ray, and this is the endpoint, right? So rays they have a definite endpoint, and then their beginning point, sorry, and their endpoint just keeps going forever and ever and ever. Okay, so as we look here, this is for an angle. The way that we measure an angle is from the initial side, and the initial side is always on the x-axis, right there. The terminal side is the side that we measure to. Does that make sense? Initial side is where we start our measurement, and we measure to our terminal side. Okay, starting point. And terminal side, that's the position after you rotate, or the ending point. Sorry, James, I don't know. Yeah, try coming in again. Okay, so the ray, it always starts on the x-axis, and it goes to the terminal side. All these different angles, okay? Starting initial side, terminal side. And that's how we measure our angle. And our angles are always measured counterclockwise. All right? And that's a positive angle. A negative angle goes clockwise. It's kind of backwards from the way that you would normally think. Okay, so coterminal angles are two angles in the standard position with the same terminal side. So if this angle is 60 degrees, we could have the coterminal angle for 60 degrees, oops, sorry, let me go back, would be starting here, going all the way around here. So what's 360? 300 degrees. Does that make sense? The coterminal angles always have the same terminal side. Okay. The other thing, this I think is old stuff for you, but this is quadrant 1, this is quadrant 2, quadrant 3, quadrant 4. These are important because when you're thinking about, this is 90 degrees. If you're thinking about anything over 90, it's over here in the second quadrant, third or fourth. All right, guys, that is 30 minutes for us. We'll just go here. So it's important because the trig functions are different in each quadrant. All right? So That's all I have for you right now. Anybody have any questions? No, 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 no. Anybody? Anybody? Alrighty, guys. Then you are free to go. Thanks for coming. All right, guys.